Right, guys. Now let's look at question 2 of Chief Mate's Stability 2019. It says, Worksheet question 2, Trim and Stability, provides data relevant to a particular condition of loading in a vessel in salt water. This is important, guys. The stability data booklet provides the necessary data for the vessel. By completion of worksheet in question 2 and showing any additional calculation in answer book, calculate each of the following. Part A, the effective metacentric height. Part B, the drafts forward and aft. Now, whatever is inked in black, that has already been provided with the data sheet. Now, let's look at what this is divided into. The datasheet is divided into compartments, capacity, stowage factor, weight, kg, vertical moments, free surface moments, LCG from aft perpendicular, FOAP stands from aft perpendicular, longitudinal moments. Now these are the compartments. It says all holes. So capacity of holes is 14708 meter cube. The stowage factor is 1.88. So what we do is, to get the weight, we divide capacity by stowage factor. So we get an answer 7823.4 tons. We need to be very careful about the decimals, how many decimals we need to take place, because if we are over accurate or if we are under accurate, the MCA would penalize us. So, as a thumb-hand rule, all the weights and moments, let it be vertical moments, longitudinal moments, free surface moments, healing moments, they need to be rounded off to one place of decimal. No need to take it more than one. And all the distances should preferably be taken up to 3 places of decimal, like LCB, draft, KM, KB, LCF. All these things should be recommended to be taken to 3 places of decimal. So we have got weight as 7823.4. We know that vertical moments is calculated by multiplying weight into kg. So we get the vertical moments by multiplying weight into kg. There are no free surface moments associated, so I usually tend to put a dash so as at the end we don't feel that anything has missed out. The longitudinal center of gravity has been mentioned here. The longitudinal moments are calculated by multiplying weight with longitudinal center of gravity, this way. So we get longitudinal moments. Same way we have done it for number 1 twin deck, number 2 twin deck, number 3 twin deck, number 4 twin deck. All these data, weight, have been calculated by capacity divided by stowage factor. And all the vertical moments have been calculated by multiplying weight times kg. All these longitudinal moments have been obtained by multiplying weight times the longitudinal center of gravity. When we look at fuel oil and fresh water, we have not been given any capacity or any stowage factor. All we have been given is just the weight for each of them. So when we see further, we see that the vertical moments for fuel oil and fresh water are already given. Now since these are liquids and they are filled in incomplete tanks, so they are partially full tanks, so that means that there will be free surface moments associated with them. So we can see that in fuel oil, The free surface moments associated is 534 tons meter, and for fresh water the free surface moment associated is 76 tons meter. We calculate this free surface moments and we put here in this column of vertical moments. We have to add this in vertical moments. Free surface moments is nothing to do with the longitudinal moment. So if we go this way, this is absolutely big no. We don't have to do this. So we take the free surface moments and add it in vertical moments table. Next is light ship. Light ship is again weight and kg is given. We can calculate the vertical moments and we can calculate the longitudinal moments. Displacement final. So displacement final is sum of all this data, and vertical moments final is sum of all this data, and longitudinal moments final is sum of all this data. After we have obtained these three values, we will be obtaining the kg and lcg. So for obtaining kg, we do is vertical moments divided by weight. We will be getting the kg. And to get the longitudinal center of gravity, we do is take the longitudinal moments divided by the weight. So we get the longitudinal center of gravity, which is 68.870 meters. Again, be careful about the rounding off to the three places of decimal for LCG and kg. Once we have got the final displacement as 15040 tons, we will go into the hydrostatic particulars which is associated with the MCA exams. Since the vessel was floating in salt water, we will look 15040 tons in salt water column. We tend to find out that true mean draft was 7.200 meters. LCB was 69.94 meters and 67.13 meters. Now most of you would wondering that why not this LCB and LCF have been taken to three places of decimal. As I said, whatever we calculate, like these values and these values, they need to be taken to three places of decimal for LCG, LCB, KB, KM. But these values have straight away been derived from the data, from the tables. Same way we obtain the MCTC, which is 187.8. KM is obtained 8.33. Again, it is from the tables. We know kg of the vessel, which is 7.015. We know GM is km transverse minus kg. This will give us the final answer as 1.315 meters of effective GM, which includes free surface moments. So this is our final answer. This includes. Now the main thing which is left is to find out the trim. Now to find out trim, we need to look at a formula which is trim is equal to W times LCB minus LCG divided by MCTC. Now if LCB is greater than LCG, now let's compare these two values. This is the LCG, which is 68.870, and this is the LCB, 69.94 meters. If LCB is greater than LCG, that means the vessel is trimmed by stern. If you look at a ship which is having a center of gravity here, center of buoyancy here, center of buoyancy is acting like this, center of gravity is acting like this, the vessel is going to trim by stern. So it is very much evident from looking at the LCB and LCG of the ship that the vessel is going to be trimmed by stern. We put these values here and this here into the formula here, and we obtain the trim is equals to 85.7 centimeters. The answer what we will get will be in centimeters because we are using MCTC in the formula, and MCTC stands for moments required to change trim by centimeter. Now once we have got the final trim, which is the difference between forward and aft draft, we need to calculate trim aft. So trim aft is trim times LCF divided by LBP. We know that trim is 85.7 centimeters, and we have taken the value of LCF from the hydrostatic data, and we know the LBP of the vessel is 137.5 meters. This is given in ship particulars provided in the blue folder, or the stability data what is provided with the questions or within the examinations. We found out that trim was 41.8 centimeters. So in meters it would be 0.418. Trim forward would be nothing but trim minus trim aft. So this gives 85.7 minus 41.8, which is give 43.9 centimeters or 0.439 meters. Now draft forward would be true mean draft minus trim forward. Now as I said, I showed you a diagram here where I showed you that if the LCB is greater than LCG, that becomes evident that the vessel is trimmed by stern. So here I know that draft forward would be less than draft aft. So the trim forward has to be subtracted from true mean draft. My true mean draft is 7.200 meters. I will take my trim forward, which is 0.439 from it. So it will give me 7.2 minus 0.439. It will give me an answer of 6.761 meters. And trim mean draft plus trim aft, it will give me for the aft draft. So 7.200 meters, again 7.200 came from here, and trim aft came from here. Since the vessel is trimmed by stern, aft draft will be more than forward draft. That's why we'll be adding it. So it will give me an answer of 7.618 meters.